So a few words about me. So I'm Valentin Delaye. I'm a platform engineer at ELCA, which is a service company in Switzerland. I'm currently Jenkins maintainer and governance board member, and I maintain the Horace Java SDK, which is a CNCF project to store artifacts into OCI registry, and also on my free time doing some mentorship for the Google Summer of Code. So quickly the agenda, first about developer intent and platform engineering, some few words about Kubernetes operators and the Kubernetes resource model, few words on the operator SDK and the Quarkus extension, and some example. So if we take at an example of deploying a simple application on Kubernetes, a developer might want also to connect his app to a database. He might need as well persistent storage. He needs probably a chair on his app. But in order to achieve all of this, you need to know how to deploy this database, where, how my company is deploying those database, which storage class to use and how to provision it, how many replica do I need, what is the cluster topology, do I need to define some infinity rules, and so on. So basically what developer wants is just to define intent in manifest, and the platform handle all the rest of the logic. Some people might try to achieve this using Helm. So Helm basically helps you to package all your Kubernetes manifest into a single deployable unit in order to add the complexity, if some conditional on yes or no to deploy those templates, and the value file to customize deployment per environment. And integrates well with GitOps tool like Flux CD or Argo CD. Is probably not enough, because you might end up with something like this. So you would have, in the case of Flux, the Helm release with a set of value. For example, for a development environment, but if you are not lucky enough to have a similar cluster on your production that is probably managed by a different team, have different rules, you might need to know many things about this cluster. For example, how to connect to your database. Maybe the database team doesn't deploy those DB inside Kubernetes. You might need to add pod affinity rules. So basically, we need probably more abstraction for that. What we could achieve is using custom resource for our application. That's for development on the left. We would have, for example, the latest tag of the image, and on the production fixed tag. So all the logic about what are the elements and how to provision them is handled by the platform. So if we have an operator, we could deploy, for example, a database on Kubernetes, or eventually provision a new schema on an external cluster. We could, for example, deploy a secret with the required connection info, or if you already invested on writing a Helm chart, deploy simply this Helm release for you and pass the required value. So it would look something like this, that you would have a custom resource that depends on different elements. So that's typically what we can see on Kubernetes between, for example, the replica set and the pods. You have one resource that will own different sub-resources. So we can achieve the same here with native resource or other custom resource like Flux release or the Postgres operator if we want. So this fit quite well for a self-service platform that everything is a resource that the user can request either via UI if you have a developer portal using kubectl or any GitOps approach to store those manifests. So basically all elements of your infrastructure could be a custom resource from an application, a database, inside or outside the cluster, a firewall rule, or any element of infrastructure. So this would look something like this. In our company, we wrote a Kubernetes operator to deploy all elements of the infrastructure, all permissions, service account, and everything. And then you can have either any front end from a UI or even AI manipulating those resources or deploy them for you. So we choose to use the Java Operator SDK, which is a CNCF incubating project to build Kubernetes operators for Go and Java. We choose the Java implementation mainly because of internal libraries that we were using already in our company, and because most of our developers know Java better. And this operator also comes with a Quarkus extension that facilitate the deployment and also allow you to deploy a native image. So some example, on the left you just need to write some custom class with some annotation, and automatically the SDK via the CRD generator will generate the definition for you. The opposite is also possible if, for example, you want to integrate your operator with other operator. You can just ingest the schema and generate the Java model for you. On operator, there is the concept of dependent. So if we just think about the previous example of database, if we want to deploy one, we could use a deployment by specifying the image and all the attributes. This is a very simple example, but in reality you will have more resources like service, secrets, and things like that, or even rely on another custom resources. But that's how we could define the state of a dependent resource. If we want to do it for an external resource that is not on Kubernetes, so if we have, let's say, a database cluster that is managed by another team outside Kubernetes, we need to use those polling dependent resource, because we cannot receive event from Kubernetes, so we need to poll to check for change. So the same will define the desired state, a create method that will create the database, so perhaps invoke some web service or whatever you need to perform this creation. And on the fetch resource is the method that will observe the resource checking if this database exists. If not, create it. You need to define resources for that, for the operator to watch them. Sorry. And then how to wire all of this together is to write the reconciler, so the controller that will create the resource. So the interesting part is the definition of the dependent. So we could have also some condition here that we can implement to know if a dependent resource is defined or not. So that when you create your custom resource, you don't need to know about the underlying cluster. If, for example, you need to deploy a database or not. On the reconcile method, you can check that if all the dependent resources are ready or not, and then patch the status of your resource, or at the end use a ready state. What we learn about writing a custom operator is that on the previous example, we just use a single state for the statute. Most of the time is not enough. So there is a pattern on Kubernetes to use a condition in statute. So it's not enforced by the SDK, but I strongly advise to follow this pattern now. What we learn is that we are using this operator to create a lot of external resources. So we needed to monitor closely what happened, because if not, you might end up creating a lot of load on your external services, especially when the operator restarts, that you will try to reconcile all the resources. Events are also an interesting way to report status to the user of those resources. Those operators can be tested, ensuring that the code that you write behave correctly. And also something that we noticed on many different public controllers is that they don't define custom columns that are always useful to directly report information to the users. Well, several challenges we face, some technical or non-technical. Current state to finish with this. So we are running this 6 months in production and already have more than 8,000 custom resources managed by this operator. So the migration from all traditional automation to cloud native. We also had to define the max loop in parallel just to avoid the load on our external services. So that's pretty much all on my side. It was a quick talk. So feel free to chat if you have any question or ask me now. Thank you.
Thank you for the presentation. Any questions while we switch the speakers? Okay.
Yes, can you describe a little bit better what it means to add a custom column as you described before? And also if you can give some more details on how you handle the final state of the CR.
So basically on the custom resource definition, you can define via JSON path the custom column that will be reported when you do kubectl get. So on the operator is basically annotation that you add on your Java code, but behind the scene, it will generate those JSON on your custom definition. So yeah, and the second question was? Sorry.
About the state, how do you structure it? You said there's a pattern for doing this?
Yeah, so, well, at the moment we are using, let's say, Backstage as a front end for our developer portal. So everyone that requests a new service, a new resource, go through the Backstage, and then we just create the custom resource into a GitOps repository. And then, the way we structure is that, well, we have quite a lot of dependency also between our CR. So I guess depends also the service you try to provision. I hope I answered the question. Thank you. That's all. Thank you.
Yeah. Thank you for the presentation, Valentin.